my name is Madison Zapata, and this is my membrane concept map. I started the concept map with plasma membrane, and I separated up into several different groups. For the first group, I did phospholipid bilayer because plasma membrane can contain a phospholipid bilayer. Found in the phospholipid bilayer, you can have glycoprotein, which I linked with proteoglycan. What describes the phospholipid bilayer is the sandwich model. The phospholipid bilayer contains a hydrophobic head and a hydrophilic head. Something that contains both hydrophobic and hydrophilic regions is an amphiphilic molecule. Something that allows something that's hydrophobic and hydrophilic to mix would be a detergent molecule. Because hydrophilic is nonpolar, I linked those with saturated and unsaturated fatty acids. For my next link, I linked it to the fluid mosaic model that proposed that plasma membranes contain membrane proteins. You can have multiple different types of membrane proteins, two of them being peripheral membrane proteins and integral membrane proteins. A form of integral membrane protein is the monolayer associated protein and the lipid-linked membrane associated protein. An example of a peripheral membrane protein is a protein-attached membrane associated protein. Membrane proteins also contain enzyme membrane proteins, transfer membrane proteins, receptor membrane proteins, and anchor membrane proteins. The plasma membrane also contains membrane channels, and ways that the membrane channels can be used is through passive and active transport. A form of passive transport is channel-mediated passive transport. For the next group, I grouped plasma membrane has selective permeability and simple diffusion. Under selective permeability, it's driven by osmosis. Forms of osmosis, you can have hypo, hyper, and isotonic solutions. Osmosis is driven by concentration gradients, and a form of concentration gradient is electrochemical gradients that ion channels use electrochemical gradients. And that's it. Thank you.